may not know, but RPI is one of the few universities in the world that actually has a quantum computer.
The large chandelier looking thing with a bunch of wires, that's what the quantum computer looks like on the inside. You basically have the chip that's at the very bottom, and you have a lot of wires and cooling to basically keep this thing very cold so we can use it. So regular computers have bits. So bits basically are ones or zeros. Now, in a quantum system, it's not the same. You basically can have it's either on, off, or a combination of both. You basically have the probability of it being in one state or the other. You don't have it being as just one state or the other. So this basically allows us to have a much larger space to explore. It's a superposition of all the possible outcomes.
It's both. Google announced they did a calculation in a few minutes that would take, what, 10 septillion years to do? And it's the parallel nature and the geometric nature of how fast these calculations can be done, which is why this is so exciting. It's that power of 2 to the n in parallel processing that makes it so crazy.
So it replacing an exascale supercomputer data center. 70 qubits representing paving the whole earth with data centers. Now I only have 70 little atoms that are doing that, right? So you can see now where the power of this comes from. We're right on the cusp now of doing scientifically useful calculations, and then doing industrially useful calculations will take a few more years to get to the point where the technology can do that.
I think we will see a real fault-tolerant quantum computer within 3 to 5 years.
Right. And if you think that all of that computing power can be replaced by potentially one quantum computer of a much smaller footprint, then you start thinking about what are the implications of running AI on a quantum computer, right?
There's many different ways of making a qubit. In the end, there's going to be one right way. Each one of them today has their pluses and minuses. What that means is whoever gets there first is likely to stay ahead permanently.
There's more demand now for folks that are quantum literate than there's more job opportunities than there are students out there, or more people out there, quite frankly. So there's a demand right now. And the great thing is that you don't have to be a physicist. Like, this is going to touch every industry. And so just being aware of what quantum computing is all about, regardless of what your major is, it's going to touch it. And you should try to understand how it's going to touch it and find those opportunities.
The last year or two, since we got this computer on campus, there have been a lot of activities going on campus in terms of the educational component. So it's not just research. There are collections of courses or pathways that we already designed. We are building all levels of degree programs, but even without a degree program, we have already, I think, 10 plus courses across the campus for people to take at all different levels, at undergraduate level, at the graduate level. If you're interested in just getting your feet wet and taking a few courses to explore, we have all of that. And if you want to do the concentration, like you say, if you're in my department, for example, you want to do a concentration in quantum computing or quantum hardware or quantum algorithm and such, that's very easy to do because we already have all those courses available.
It's very accessible to undergrads, and there's also a lot of resources online to at least get all the original information, like how to code on it, how to do all the small things, and then you can go and engage with all the course material and the undergraduate professors that are offering a lot of research. Importantly, as well, this is like all the kind of professors are offering undergraduate research and will include you in these small little projects that they can. They'll give you a small piece of what they're doing, which is real work in the field, and get your experience in there.
I would just say join the Quantum Club.
Some of the research that's going on in RPI right now is focused on how do you integrate a quantum computer with a classical high-performance computer, with the supercomputing system that they have at the tech park. So linking those two systems together and then feeding back in real time the quantum result to the high-performance classical computer, and then looping that information back to the quantum computer and so on. So it's like this big hybrid heterogeneous system, because computing in general is on this march towards heterogeneity.
Given the amount of research happening, even in the first year, it's pretty impressive. And I think that the next 2, 3, 4 years, as the university digests this stuff and gets it more built into its kind of DNA, you're going to see a lot more interesting research happening and a lot more funding happening, because it takes time for these grants to get processed.
Whatever. This is the type of complex, cutting edge education that will prepare you literally for anything, med school, law school, doesn't matter what it is. Well, you've got great schools that you can go to, including RPI. If you go to RPI, it's a problem-solving education, and that's what employers are looking for. RPI will bring you the problem-solving thing, and on your own, just work on your personal dynamics and your ability to function on teams and that kind of thing. You're going to have unbelievable job opportunities.